Good morning, majors. So today we're going to go over Unit 9d3. This is going over central and inscribed angles. So a central angle is going to be an angle with a vertex on the center of the circle. A circle is 360 degrees. 360 degrees means going all the way around once. The measure of a minor arc is the same as its central angle. Okay. So whatever the central angle is, that'll be the same as a minor arc. A semicircle is exactly, this means, semi means half of a circle, is exactly 180 degrees. So that's half. So N to P is half of a circle. So let's try an example. It says given R is the center of the circle. That's given. This is my center. Find the measure of each arc in degrees. So find the measure of MN. Arc MN, I'm going to underline it in red. This is what I'm doing. The measure of arc MN. M to N is this arc right here. It's going to be the same as this central angle. This is my central angle is 80. Then my arc is 80 degrees. So the measure of angle, this angle right here, remember we name it with 3 letters. And that'll be NRM is 80 degrees. NRM is 80 degrees, which means my measure of arc MN is 80 degrees. Okay. Now, what is the measure of PM? We don't know what PM is because we don't know this angle. But we know that if this part is 180 degrees, then the other side has to be 180 degrees. So 180 minus this 80 means this angle right here is 100 degrees. So I know that M to P is equal to the measure of angle. Remember, R has to be the middle, and I have to have MRP or PRM, as long as R is in the middle. So I'm going to put PRM, which is 100 degrees. Now, these are called minor arcs because we only use 2 letters. They're less than 180 degrees. But when we use 3 letters, P, M, N, then it's going to be half of a circle or more. So PMN is exactly half of a circle, right? It's 80 plus 100. It's half of the circle, which is 180 degrees. This is a semicircle. M, P, N. M means we're going to start at M. We're going to go along to P and then along to N. So we're going along from M to N, but the long way. So we're going to say it's, well, a whole circle is 360, but we're not using this part right here that's 80. So it's going to be 360 minus 80. So just plug that into your calculator. 360 minus 80 is 280. So this whole blue part is 280. 280 degrees. Arc addition postulate. Addition postulate says the sum of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So it says find the measure of each arc in degrees. G to E. G to E is adding up 2 arcs. It's going to be 40. G to H is 40 plus H to E, which is 80. So 40 plus 80 is 120 degrees. So you guys can try the rest. Just add them up. An inscribed angle is going to be an angle that has its vertex. Remember, the vertex is D. The vertex is on the circle. So instead of meeting in the middle, we're going to pull it all the way back like a slingshot, and it's going to go all the way back to the circle. It's going to be touching the circle. The arc that lies on the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc of the angle. Okay. So the inscribed angle is going to be angle, we can say ADB or BDA as long as D is in the middle. I'm going to say ADB. That's how we name an angle, 3 letters. ADB. The intercepted arc is arc AB. This one right here. This is my intercepted arc. My small arc. Alright, so formula for measuring an inscribed angle. Your inscribed angle is going to be half of the arc. So I'm going to write that out. We're going to say 2 times the measure of angle ADB equals the measure of the arc AB. Or the opposite is the measure of arc ADB. So this arc angle 1 is equal to half of the measure of arc AB. We'll do some examples on this. Okay, so this is a 90-degree angle. This little boxing means 90 degrees. So the measure of arc QTS, this whole arc right here, is 2 times 90, which is 180. It's half a circle. All right, let's try this. If they give you the arc, which is, they said in this case is 120, and they want the angle, the inscribed angle, MNP is this angle right here, then we have to divide it by 2. So 120 divided by 2, I think, is 60. So it's smaller. Doesn't it look small, though? That's how I think of it. We know it's either multiplying or dividing by 2. Doesn't it look smaller than this arc? So we're going to divide the big one by 2 to get the small one. All right, guys, I want you to try out the other ones. Ooh, that one you can do. But let's try this one. So if this part right here is 224 degrees, we need to subtract it from the whole circle to find the angle B. Okay, so we know that a whole circle is 360 minus the 224. That will help us find B. So 360 minus 224 is 136. So this part right here is, this arc is 136. But we know that my angle A is smaller, so I'm going to put B first. B is 136 degrees. Now, angle A is going to be half of that. So if you divide that by 2, we're going to get 68, and A is 68 degrees. If 2 inscribed angles of a circle intercept the same arc, then the angles are congruent, because they're both half of that arc. So if AEB is 40 degrees, then my arc A to B is twice that, right? It's 80. So that one is one question. But then they're saying, what is ADB? But my endpoints are still on A and B, so it's still half of 80, which is 40, right? And then they're saying, what about ACB? But my endpoints are still A and B, so it's going to be the same. Tell me what ACB is. And an angle inscribed in a semicircle is a right angle. Remember, a semicircle is 180 degrees, and if you divide that by 2, that'll give you 90 degrees, which is a right angle. So this is a lot. This is all about circles on the inside. So when 2 chords intersect in the inside of the circle, the product, which means multiplying, of the lengths of the segments of one chord is equal to the product of the other chord. So I'm going to give you an example. What I just say is stay on the same line. So I'm going to stay on the same line. This is all one line right here. 3 times, stay on the same line, x equals, we're going to change lines. Stay on the same line. 6 times, stay on the same line, 4. You have to multiply it. 3 times x is 3x. 6 times 4 is 24. And then if you divide both sides by 3 to get rid of that 3, we're going to get x equals 8. X has to be 8 for this to be true. So try the other ones. The owners of an outdoor adventure course want a way to communicate to all the points of the course. They are considering purchasing walkie-talkies with a range of 4 miles. The model of the course is below. Each grid represents 1 mile. The base station is at 2-4. Do you think the base owner should buy walkie-talkies? Why? So it only ranges 4 miles. I want you guys to try this one out. This is a really good real-world example. This is going back to what we know about an equation of a circle. So you guys we already went over this. This is going to be on your quiz though, making sure you understand what a point is. I want to go over this, or the equation of a circle. You guys really need to know. It says, given this equation of the circle, is this point on the circle? So it gives you a graph. You don't really need to graph it, but we can. It says that my center, remember we're going to change the sign. Since it's -1, it's going to be +1. Since it's +2, it's going to be -2. So I'm going to plot that. My center is at 1, -2. This is the center of my circle. And my radius is not 16. My radius is the square root of 16, which is 4. So that means I'm going to go to the left 4. I'm going to start at my center, and I'm going to go to the left 4. I'm going to go up 4. I'm going to go to the left 4. And I'm going to go down 4. Alright, and I'm going to just draw a circle. Start at the center and connect the dots. And it says, is this point 5, -2 on your circle? So we're going to go over 5, 1, 2, 3, 4, 5, -2. Yes, this is on your circle, right? You can say yes. But sometimes it's hard to see. So you guys can try this one. Let's look at this one. -3, -6. -3, -6. I'm not sure. I don't think this is on my circle. What if I actually did it wrong? Let's see, -3, -4. See, I'm not sure if these two are on the circle. What we're going to do is we're going to plug it into this equation of a circle. So this is my x value, 3, and then -4 is my y value, okay? So I'm going to plug it in. My equation is x minus 1 squared plus y plus 2 squared equals 16. Are they equal? So I'm going to plug in 3 for the x value minus 1 squared plus -4 plus 2 squared. Does that equal 16? I'm not sure if it equals 16. Does it equal 16? 3 minus 1 is 2. Squared is 4. -4 plus 2 is -2 squared is 4. Does that equal 16? 4 plus 4 is 8. Does 8 equal 16? No. No. So that means it's not on my circle. Try the next one. Find out if it's on the circle. And that's going to be it for today. So make sure you guys go over this and you're ready for your quiz. The next class, we're going to have a quiz. And have a good night. We'll see you in class tomorrow.